Today I'll be going through how to evaluate this integral. Firstly, I'll need to find the indefinite integral first, and then I'll find the definite integral. Finding the indefinite integral first and then putting the limits later will help us not to confuse ourselves. Because if we put in the limits and we use U substitution, we will need to change the limits of the integration. So first, how do I solve the indefinite integral? We'll let U to be the entire radical. Once we have let U to be the entire radical, no matter how we do the differentiation, we will not be able to get dx to be substituted in terms of du. So what do? We can square the radical so that we can remove the square root and perform a rearrangement. So we square both sides, we get u squared to be equals to ex minus 1, and then we'll bring the x terms to the left hand side. So we have ex equals to u squared plus 1. Take ln on both sides, we get x is equals to ln u squared plus 1. Then only we can find what is dx over du, and this is equals to 2u over u squared plus 1. Therefore, I have my dx to be equals to 2u over u squared plus 1 du. So this dx, I will be able to put it back into the indefinite integral, and then I can solve the integration. So let's evaluate this thing first. E to the power of x minus 1, and take the square root, dx, and this is equals to u multiplied by 2u over u squared plus 1 du. Now everything is in u, we can do the integration. First, we can bring the constant out, and then we multiply u in, so we get u squared over u squared plus 1 du. And notice that this is an improper fraction. For improper fraction, we can do long division. Otherwise, we will just perform a shortcut by adding 1 and minus 1 on the numerator, so that we can isolate these terms, and these terms will essentially become 1. So this can be evaluated as 1 minus 1 over u squared plus 1 du. This integral, we can solve it. So it's 2 u minus tangent inverse u. And what is u? U is e to the power of x minus 1 square root. E to the power of x minus 1 square root minus tangent inverse e to the power of x minus 1 square root plus c. So that's it for the indefinite integral. Now we can solve the definite integral. It's just putting in the limits from 0 to ln 2 e to the power of x minus 1 dx. Since I have the answer over here, I'll just copy it here. So I have 2ex minus 1 minus 2 tangent inverse ex minus 1, and take the square root. And this entire thing will go from 0 to ln 2. For this equation, I can just press the calculator to obtain the solution. So I'll obtain 2 square root 1 minus 2 tangent inverse square root 1 minus 0 minus 0. This thing will essentially become 2 minus pi over 2. And that's it. We solve this definite integral. So just remember, for our integration, solve the indefinite integral first, especially when we are dealing with a u sub. After we solve this, then we transfer to our definite integral, put in the values, and then we can get the answer.